Okay, guys, we're going to look at section 1.1. And this is just going to basically be a lot of introductions to some vocabulary and things like that that you need to know. So the first thing is statistics, okay? And one of the things that I want you to know here is that the word statistics with an S is the class, okay, is the actual study of collecting, describing, and drawing conclusions from information. Here in a second, we're going to have just the singular of statistic, and that has a different definition. So statistics is this, and basically in a nutshell, we're going to be getting information, sorting through that information, seeing what that information can tell us, and then drawing conclusions from that information that we're able to pull. So a population is the entire big set of individuals that you're getting. Now, a population does not have to be huge. I mean, it can be. It can be all citizens of the United States. It could be all citizens of Texas or all citizens of Tyler. It could be all Tyler Junior College students. But it could be something smaller. It could be students in TJC students in statistic classes. And so a sample is a subset or a smaller group of that bigger population. So our class of statistics students would count as a sample from the larger group of all TJC statistics students. It would also be a sample of TJC students in general. So now the next thing is what's called a simple random sample, okay? Now, first off, there's something called a random sample. A random sample is everybody's name is in a hat. I'm gonna draw, I need 5 names, I'm gonna draw 5 names out of the hat, okay? Straightforward. Now, what a simple random sample is, we're going to take every possible group of 5, okay, from a class or from a group, and we're going to write those 5 names down on a slip of paper, okay? So I've got Adam and Bob and Charlie and Dylan and Eddie, okay? And then I've got Alan and Bob and Charlie and Dylan and Frank, and Adam and Bob and Charlie and Dylan and George, okay? And I've got every possible group of 5. So in a simple random sample, all of those group slips are in the hat. And all I have to do is draw 1 slip of paper. And I've got my 5 names. If I need another group, all I have to do is reach in one more time and grab 1 more slip of paper, okay? So they give the example that it's kind of like the lottery. If we've got 10,000 lottery tickets are sold and 5 are drawn as winning tickets, each group of 5 tickets that can be formed. So they're basically saying I've got 5 sets of winning numbers. That pull of 5 numbers is going to be what is the draw off, okay? So next one is sometimes it's really difficult for us to do random sampling, okay? So sometimes the only option we have is to do it by something that's really simple or really quick and fast for us to get. These are often called samples of convenience, and samples of convenience we have to be very cautious with, okay? They don't generally have real great data significance because they're not really truly representative of our overall bigger population, okay? And so, for example, if we were going to, let's take, the city of Tyler, and let's say that there was a 2% homeless population, and we were wanting to sample and get information about whether or not we should do bus routes, okay, some new bus routes or something like that. If the only people that I talk to when I pull my sample, if I don't have, let's say that I had 100 people in my sample, ideally, I would like to have 1 or 2, maybe 3 of those be homeless individuals. But if I don't have that, because I just walked down to, the Brookshires and I grabbed the first 100 people that I saw, that may be a sample that is drastically different than the actual population makeup of Tyler, okay, as far as where people live and modes of transportation and things like that, okay? Now, sometimes, as long as we can show that our convenience sample truly is pretty close to reality, then we can probably be okay. But again, it takes a lot to try and prove that, okay? Now, the next type is what's called stratified, okay? So with stratified, what you're going to do is you're going to divide your groups up. You're going to divide your big population up into groupings, okay? And the big thing with groupings is every individual has to be classed into a group. Your groups can't overlap. So this may be things like age. I could do 0 to 9, 10 to 19, 20 to 29, 30 to 39. So they're non-overlapping. I could do by zip code. So 75701, 75702, 75703. And those would be. Then what we do is we take a small sample or a sample out of each one of those. Okay, so I'm going to get 100 people out of each zip code. Now, the visual that I like to give my students for this is imagine one of those layered rainbow jello desserts. Okay. Okay, it's gorgeous. It's pretty, red, orange, yellow, green. It's gorgeous. Okay. Now take a straw. I'm not talking about one of them little chintzy straws. I'm talking like, McAllister's, Taco Bell slushy type ones. Okay. The big pipeline ones. Okay. And punch it down through to where you go through every single layer in that jello. Pull it out. That little rainbow worm looking thing that's going to come out of that straw, that's a stratified sample. Okay, I've got a little bit, but I have every single color represented in that grouping. Okay, now cluster sample, a lot of students will confuse cluster sample with the stratified sample that we just talked about. Okay, in a cluster sample, you still divide the population up into groups. So you may still be doing by age or by zip code or something like that. The difference here is that you're going to select a few of those groups and you have to talk to every single person in those groups. Okay, so if I was going to do zip codes and I picked 75703, 75707, and 75708 for Tyler, I have to talk to every single household, house, individual, however we defined it, in 75703, 75707, and 75708. Okay, now the visual that I do for this is go to a wedding, go to a party, go to a buffet where they have a fruit, where they've got fruit out. Okay, a lot of times when they put the fruit out, especially for grapes, they put them out in the little clusters. They don't put the whole big bunch of grapes out there. Okay, they break them off into little clusters of 3 or 4 or 5. Now my kid loves grapes. Okay, and when he would go to stuff like this, I would let him pick 2 or 3 or 4 little sets of grapes. Okay, but every set of grapes that he put on his plate, he had to eat every single one of those grapes. Now there were grapes still left on the table. There were clusters of grapes still set over there. I wasn't worried about those. But of the clusters that he took, he had to eat all of the ones that he took. Okay, so in stratified, it's a little bit out of every single layer. In cluster, it's everything in a few of those groups. Okay, now the next one is systematic sampling. This is where you're going to put a pattern on it. You're going to talk to every 10th person or every 5th individual, or I'm going to pull every 100th item off of an assembly line for product testing, whatever. This is what's called systematic or systemic sampling. Now, this is how Walmart, for example, does who gets surveys on their receipts. So somewhere in their system, they've got a pattern. I don't know what it is. Maybe it's every 7th person, every 7th transaction. Okay. Now, it's not every 7th transaction on that register. It's going to be every 7th transaction in the system, because I can go in and check out groceries and get done with my transaction, and I happen to get a receipt that has a survey on it. And I look down and, oh, dadgummit, I forgot the dog food. So I scan the dog food. Now, no one has checked out on that register since I did. Okay. But if 6 other people got done, or 13 other people or whatever, got done with their transactions while I was scanning my stuff, then I could get another survey again. Okay. So that's the way that systematic works. Okay. The next one is voluntary response. Okay. This is going to be that the individual gets to choose whether or not they want to participate or not. They give the example of a radio announcer will invite people to call into the station and give their opinion about something. News outlets do this a lot, where they want to get opinions about upcoming election topics or debate topics or whatever else. Voluntary response is a version of convenience sampling, and because people are able, news media outlets and things like that are able to get opinions really quickly. The problem with them is you tend to get the really, really strong opinions. One of the cases that I remember is back when Tyler was deciding whether they were going to stay wet or dry. You always got the ones that were like, no, we can't go wet. It's going to cause all this crime and cause all these accidents. And we're going to see all this. And then, you're going to take income away from the towns that do. And you had the other end that says, no, people won't be driving as far intoxicated if it's here in town, and you won't have, whatever, and it'll bring revenue into Tyler. You didn't get, and those were the two extremes. And that may only represent half the population that has those extreme opinions. You didn't have people calling in that were neutral, okay, that were like, really don't care. If we do, we do. If we don't, we don't. It doesn't affect my life. And so you really only got those two. So it really looked like the opinions were very polarized and very extreme to those two ends. And there wasn't any kind of neutral middle ground. When in reality, there was, okay? So voluntary response, we don't do a whole lot with those, because again, they're convenient samplings, and they tend to be a little not as precise with those. And so the last little thing we've got here is a statistic. So this is the singular, is a number that describes a sample. So statistic comes from a sample. So statistic and sample, match those S words, okay? A parameter is a number that describes a population. Now, this may be something like a percentage or a mean or a median or whatever else. So we've got, for example, 57% of teachers at Central High School are female. This is classed as a parameter because we're talking about all of the teachers at Central High School. So that would be the entire population, would be all of the teachers. In a sample, now they already gave me that word sample right there, so I kind of already know where we're going. Of 100 surgery patients who were given a new pain reliever, 78% of them reported significant pain relief. That would be a statistic. Now, if you look at the worksheet, sorry, my brain had a moment there. If you look at the worksheet that is available, I'm going to kind of run through these examples real quick here. Okay. So it says determine, for the first one, it says determine whether the number described is a parameter or a statistic. So we have 54% of employees at a certain company are male. Okay. This is going to be a parameter because we are again talking about all of the employees at that particular place of business. Okay. So the next few want us to sort out what kind of sampling is being used. So we've got the coach gets 3 players from each grade. Okay. Now, key here is we've got a small number out of each grade. So that is going to be stratified. Okay. Next one we've got the news reporter asked everyone at the convenience store about the curfew. This one is going to be convenience. Okay. The next one that we're going to look at, okay. Again, we've got the coach. He selected varsity or JV and asks all players. Okay. And so the concept here is that maybe we have a 9th grade team, maybe we've got, an A and a B team. This one is going to be cluster. And part of that is because they said they picked all players out of this one. So number 5, we've got the student government at a certain college assigns a number to each person, puts the numbers in order, and then does every 25th. That's our key. This is systematic. Okay. Next one is we've got the note in a paycheck. asking them to post their opinion on the employee's website. This one is going to be voluntary response because they get to choose whether or not they want to participate in that one. And then the last one that we've got is we've got 500 people at a charity. They put them in a drum. We draw 10. Those 10 people. There is an argument that this is random sampling just because they did draw 10. Because they didn't exactly define a random sample, this could also be classed as simple random. Okay. So that is section 1.1.